This generics concept, which I'll show you now, will help you solve problems like this. Because the problem we have here in the end is that this type is a bit too wide. Accepting any kind of value is a bit too wide. And in addition, another problem we have here is that the return type also is too unspecific. Therefore, if I call add and I pass two integers to it, Go doesn't understand that result will be an integer. Instead, it thinks it's any kind of value. Therefore, thereafter, working with that result will be rather difficult. Because, for example, if I add 1 to it, Go complains that the types are not the same. So, of course, it would be great if Go would understand that the return value of add will be an integer if the two values we pass to add are an integer. And that's also a kind of problem that will be solved by turning this add function into a generic add function, which we do in Go by adding square brackets after the function name before this parameter list. And between those square brackets, you can define a type placeholder name. Typically that's t, but you can use any name of your choice. The idea is that it's now this placeholder that is used here instead of this interface type, for example. And you can also use this placeholder here as a return type. But at the moment, I'm still getting an error here, because we must tell Go which concrete types are allowed as types for that placeholder when add is being called. And here you can, for example, use this interface type here again, or the shorter form any, which simply means t can be any kind of value. Now, as you see, when doing that here, I'm getting a bunch of errors, but I will deal with them later. What's more important than that is that by making this simple change, if you now hover over result, Go understands that it will be of type int. And it understands this because what we're doing with this generic type placeholder is that we're telling Go that the concrete type of values we're receiving here and we're returning will only be set and known at the point of time where add is called. So in this line of code here, line 4 in my case. It's then here where Go sees that two int values are passed in, so it correctly infers that the concrete type that's being used here must be int, because I'm passing in two int values. Since I'm using exactly the same placeholder here for the return type, it therefore also knows that the return type must be int. And you could set up multiple types here separated by a comma, if you would need multiple placeholders and you, for example, would need a different return value type. But that's not the case here. I'm fine with one type. And that's why this generics feature exists and why it can sometimes, in certain situations, be really useful, because it allows you to write more reusable, more generic functions where Go nonetheless is able to correctly infer the types of values you're working with. And therefore this code here now doesn't work anymore because it isn't needed anymore. When writing this in a generic way, we can simply return a plus b, at least we can almost do that, I'll get back to it in a second, and we don't need any other checks. However, we'll still have one problem if we do it like this. Since we're saying that the concrete type that's used at the point of time where add is being called can be any type, we're of course back to this error that the plus operator is not necessarily defined for all possible types. But we can work around that by setting the base type or the range of allowed types for t not to any, but instead to a list of predefined types with which we're fine. By simply listing all those types separated with such a pipe symbol. Like this. With that, I'm saying that t can be any type as long as it's an int, a float, or a string. And therefore now this all works, and the only complaint is that I'm not using result. But of course we can change this by simply outputting it here, like this. And this code now therefore works and is written in a very generic way by using this generics feature. Now, it's worth noting that you might not need this feature here too often, because if you're writing your own programs, you don't often need code that is that generic. But especially if you're working on a library that should be shared with other people, where you don't necessarily know in advance with which kinds of values they might be using your functions, especially in cases like this generics feature here can be really useful.